So let's look at what is the actual meaning of a Cartesian equation and what's the difference between Cartesian and parametric equations. As you can see actually on this rather symmetric looking graph here, this is nothing but x being equal to cos of 7t and y being sine of 5t. You can use Desmos graphic calculator and play around with it, and you can play around with coefficients of and t here and find other nice looking symmetric graphs. Okay, so let's get to the business here. The very first example is asking us to draw a graph of this function x being 2t and y being t squared. First of all, let's understand that parametric equations are defining x and y coordinates in a third variable. So our third variable is usually t or theta if we have a trigonometric function. So in this case, we are basically bounding the value of t between -3 and 3, and we have to come up with a table of values for x values and y values, and you can use your graphic calculator. The table function on your calculator will help you calculate these values rather quickly, and plotting them is also simpler if you have to if you can use your graphic calculator to help you. That's great. Okay, so as you can tell, the -6 and 9 are the leftmost value here on top left, and +6 and 9 on the top right value there, and the minimum of this curve is at 0, 0, the origin. Curve passes through the origin. Okay, so the next part of the question is asking us to find the Cartesian equation of the graph, the curve. What is Cartesian equation? Well, we've always been using Cartesian equation. Y give, if you define y in terms of x, and that is a Cartesian equation. So we have to rewrite the strategy is to rewrite the value of x in rather rewrite t in terms of x and substitute that value, that expression, into the second equation. So if we call this equation 1 and this equation 2, first we rearrange the value of uh, that first equation so that x will be, now t will be the subject of the formula, so x over 2 equals to t, and now we substitute this t value in into the second equation, where t squared, we have t squared, that means that x over 2 must be squared. Therefore, we can eliminate t and have y being equal to x squared over 4. And that's the meaning of a Cartesian equation. This is the final answer we're looking for. Now, Cartes was a French mathematician who lived about a couple of 3 centuries ago in Netherlands actually. Okay, so let's look at the next example together. In this example, once again, we have been given x in terms of t and y values in terms of t. Questions asking us to find the Cartesian equation of the graph, where x is larger than a constant k and k to be found. Well, we know that we cannot take log of any negative values. So therefore, the input into this function, logarithm function, must always be positive. Therefore, t plus 3 must always be positive. Okay, so t, therefore, has to be always larger than negative 3, strictly larger than negative 3. Now, they actually give us the fact that t is always larger than negative 2, which is even greater. That means that log is always, we always have log of 1 here, and log of 1 is always larger than 0. Okay, so to find the Cartesian equation, what was the strategy? The strategy was to use the equation that x is defined in and make t the subject here of this formula, make t the subject of this formula, and substitute that t into the second equation. Okay, so let's do that quickly. We're going to use the inverse logarithm, that means exponential. So e to the power of x is t plus 1, t plus 3, subtract 3 from both sides, and substitute this expression of t into the second equation. So 1 over e to the power of x minus 3 plus 5 can be simplified to a plus 2. So we can finally write it as such. Okay, so that's the meaning of Cartesian equation there. Now in the second part, well, this is just defining that the range of these values will be always positive. X will be always positive. Therefore, the lowest value for x is 0. So when you substitute 0 into this function here for x, we will have 1 over 2, well, 1 over 3, because 1 over 1 plus 2 is 1 over 3. Now, as what is the limit as x increases? As x becomes a larger and larger value, the expression here, that means that the denominator is becoming larger and larger. Therefore, as the denominator becomes larger and larger, we will approach 0. So 1 divided by a very large number is approaching 0. It's not exactly equal to 0, but approaching 0. And so x cannot be negative, so even if it was, then we would have also go to the left of this graph, which looks like so. So we have basically that is approaching 0 as x values get larger and larger. Okay, so here we are substituting the fact that t is minus 1. So the constant here is the value of x is bounded. Okay, so in part B of this question, we were asked to calculate the range of f of x. That means that what is the y value of what range of values will y value take? Now that we defined y in terms of x, uh, if you consider this, y is f of x. So we are exploring what's happening as we came up with the fact that x will be always a larger value for so x is bounded by 0 below, and it's not bounded above. So what happens when x increases, uh, and what value does this expression approach? Well, the e to the power of x will explode in the denominator, so it will become a larger and larger value, and 1 divided by a very large value will approach zero. So therefore, y value will be approaching zero. So the curve uh, will have an asymptote of y equal to zero, but approaching that asymptote, it's vertical asymptote, it's a horizontal asymptote. Now, what is so y is bounded below by zero, but what's the highest value of y that y can take? Well, y is because of the reciprocal nature of this one y is reciprocally related to e to the power x plus 2. Therefore, the lowest value of x actually will give us the highest value for y. So the lowest value for x is 0, and if we had substituted 0 there, we would have e to the power 0, which is 1, and that would be 1 over 3. So 1 plus 2 in the denominator is 1/3. So y will be strictly always be will be strictly less than 1/3 because x cannot be 0 itself. So be careful. There's a strict inequality between x and 0. Therefore, y is bounded below by 0 and bounded above by 1/3. Okay. So let's look at the next part of the graph, next part of the question. Okay, so here is actually the professional graph from Desmos that we can uh, get ourselves. So as you can tell, because our x values are always larger than 0, we only have the right half of the graph in our function f of x. Okay, so I will leave you to practice these questions from 8a, and I will see you in the next video.